everyone. My name is Amy Jo. This is my project. It's a test for the bicycle performance along the Cass corridor of Detroit using smartphone GPS data. The data I collected is from my own smartphone and using the smartphone apps. Also, I had a GoPro installed on the bicycle so that I can record some performance along this riding experience. First of all, I want to have an overview for the contents of my presentation. It has the object, procedures for the data collection, how I clear those data, the method I use, the analysis part, the result, and the conclusion. The pictures shows how we say define a road segment. This is one road segment. It's between two intersections. So in other words, if you're talking about one road segment, it means the distance between two intersections. So how does the CAS corridor bike performance for bicycle? That's the objective I want to test. And then I have a small video recorded that how it might impact it when you ride over there. The intersection wise, the signal timing, maybe some reasons that can make you riding faster, and you might riding slower when you see the pedestrian crossing or stopped. And pedestrian at the same time also will their behavior will also change when looking we seeing a bicyclist is riding through, and you might slow down when you see a car is doing the left turn or right turn, and then when the signal timing is too long, the red light is too long, people tend to not behave right, follow the rule. The collection app I use for one is the app is called Tracker Client. It's called Tracker, and another app I use is Strava. The reason I use two is because I think I have this Tracker app is pretty good sit and a good stand, and then the other one, the Tracker, is the popular one. So in other words, the Strava test in the recent studies for the pedestrian bicycles, most of the suggestions using the Strava because it's a widely used app that by the bicyclist professional, and then you can easily get a lot of the data if you paying for this for the company. And then the other one in the country is a free app, so that's why I want to use that. So we have the own access for all the data, and also we can customize for how we're gonna collect that, how much frequency we want to log into one data, and the other options like how many distance we traveled around to log into one data. But Strava don't have those flexibility. It's preset and also is not stable. Sometimes it might log in 1 second, or sometimes 3 seconds, sometimes 10 seconds. So the whole driver riding this riding route is from the start point to the destination to the end point of this um, Cascade or bikeway. Um, I ride from the New Center part, the Grand Boulevard, to the Jefferson Avenue, to the downtown area for this test. The road segment data, I need several resources to collect it. What I need, first one, the access points that the driveway entrance that you are passing by. Those are called access points. So in other words, you have seen more driveways that you might have more cars to interrupt your riding. This is one popular variable that people decided the performance impact. Then the signalized intersection, whether it's signalized or not signalized, how many lanes I need to cross the street. And those are collected by aerial map. This is the most traditional way, but it's also guided by the highway capacity manual of the recent version because we don't have available data. Then the second one is a land use map from the data driven Detroit. I want to use that is because I think the different buildings along this corridor may impact my riding speed. For example, mm, you have some people cross the street for shopping, and then you have more frequency that interruption, more likely to interrupt it by the commercial area. And if you have some high density residential area where you have also have some interruptions, maybe not strong as commercial area, but also maybe have some impact at certain time. Also, what about the industry? If you in industrial area, if you have some long trucks that interrupt you. And the third one is the population data I got from the Asterisk resource, but it's not free to download. It's have to use that and manually type into my Excel file for data editing work. The last one is the red light frequency that which mean this frequency means how many times while doing the reading test, how many times I see the red light. If some segments whenever I do the writing test always stop there, that also can reflect something. And my original data looks like this. These total of the observations are 406, and then it's for one single trip. Then only used for data are the time, longitude, and latitude for the speed test. Same as the Strava. Um, Although the tracker do already design there's a speed data already collected, but the result shows it's incorrect, so we cannot use them. Then in order to do the use those data, I need to clarify my start point and end point for my whole trip. That the points that I have not started to write or I already started to write just outside of this time range will be cleared out. And then with this longitude and latitude geographic coordinate data, I want to convert them into normal distance by miles, and then using that and with the timestamps that I can calculate the speed. So that's why I add in the four variables, the following variables. Mainly is want to get the speed data. And the segment data as looks like that. The map is the resources that we have that defining along the street and different colors representing the usage. The red representing the commercial area, purple representing the industrial area, the yellow representing the residential area, blue representing parks, the green representing the parking area. However, if you see our data map, it only has three colors, which that's all the variables we are going to use. So we just manually I have to manually calculate each of the segments and use and record what are those zonings I passed by. And then the data is shows like that. The zoning code with C is representing commercial area that I actually you can see the whole corridor passed by a commercial street, and then mixed with some with residential and some with industry. And these pictures below shows the proof that why I have to do this way, and this is the recommendation from the manual. And the population I used from the ArcGIS training course that they do not allow it to download. So also I need to click each of the census tract area, and then on the left side to check how many residents live there, and log into those data. And the segment ID that it's each of the segment I pass by, we're using the unique number to identify those. And segment lengths and travel lengths are the distance that using miles to measured. The number of access points, how many driveways that I pass along on each of the segments. Are there any signalized intersections ahead? How many red lights at this intersections? 6 segments in front intersections. I'm being suffered. Um, then how many lanes that I cross for each of the intersection. A final version of the data, I only have 12 variables, and the response is the speed, and the factor the segment ID is a factor variable, and the signal timing signal intersection zoning are the dummy variables. I'm using the multilinear regression model, backward step function, and the pairs to test my model. And then from the left side, you can able to see have the a general picture about how those writing changes over the whole period. There are some outliers, of course, but overall, when we have the regression, it's going to be the general majority of the right observation is going to dominate the analysis. So and we can see that some lines that the bottom of graphs that you can see some lines that are approaching to zero. That means that those intersections that I stopped. My regression model result doesn't show very significant result that I like, because they said 7 of the defined not defined because of singularities, which are the variables that I all cared. And then I had the backward deletion. Then start from the AIC 890 and then down to 830. So it's a pretty significant change. And then it shows that speed had a significant relationship with this segment. And each of the segments do have the positive and negative. Shows that bicyclists tend to ride faster at the positive coefficient segment and slower at the negative coefficient segment. We do not want it to be very fast because it might also cause some pedestrian safety issue if it's over speed. And then in order to improve those segments that underperformance, I want to test another linear regression model without the segment ID, and then test something like the access points, the lane-wise census tract zoning, which can maybe if we can improve that those variables and we can change the performance, then the model shows very significant results. And although there's only one zoning industrial category doesn't show significant value, but they are pairs value, so it might be useful. And we can see this backward deletion that end up didn't delete anything. So that proves that this model actually is the best model for the segment performance. And then the pairs model shows the strong linear relationship between travel distance and the time, which is of course that you travel longer and then you travel further. And the segment ID doesn't show really actually too much meaning because it's vector variables. And finally, the conclusion is that different segments do have different impact on the bicycle speed. And my future works will compare the Strava data with this model and to see is it a good fit. If it's good fit, we can substitute this tracker Strava data into tracker. If it's not, we'll have more study. That's all. Thanks for watching.